Hello, we are the South Dakota State Moon to Mars Ice and Prospecting Team, and this is JAMMER, the Jackrabbit Automated Moon to Mars Prospector. Currently, we have completed manufacturing and bench testing all full-size systems. Our next step is to integrate all subsystems into the main frame to test the full system. We will show progress from each of the main subsystems individually: drilling, digital core, ice melting, pumping, and filtering. To create our drill bit with a hollow interior, we manufactured many prototypes at half scale as well as a full-scale final model. We learned a lot about CNC manufacturing as we manufactured all components in our shop using a 4-axis CNC machine. Our last prototype features exterior flutes on a hardened steel tube with hollowed out rock boring drill tip that's welded onto the end of the tube. The inside is an 18-inch Bosch masonry drill bit with an 18-inch SDS extension rod. Our bit is powered by a Bosch Bulldog rotary hammer, which has been deconstructed and draws less than 9 amps. The drill is fastened to a 3D printed load cell carriage inlaid with carbon fiber. Recently, we tested our full-scale drill in hardened concrete, which is what we expect to be one of the most difficult materials to drill through in the overburden. Our system is functioning as expected and is able to penetrate through concrete. During normal JAMMER operations, the digital core collection system will be simultaneously collecting vibration frequencies as well as power, current, and drill vertical speed through the layer. Also tracked will be the vertical depth and hole by counting steps on the stepper motor. Shown here is a bench-tested vibration monitoring system along with a plot of a real-time output. We have gone through many iterations of a heater core assembly, but we have decided to go with a 3D printed aluminum design which houses 4 electric resistance heater cartridges and boasts interior geometry enabling both recirculation of water in the ice hole as well as removal of water from the hole. Some of these iterations can be seen in the picture. Plastic 3D printed cores were used in the geometry of the holes for recirculation to promote better temperature distributions within the hole. Living in South Dakota, we were able to test for several weeks outside at temperatures below negative 20 degrees Celsius. In fact, we had temperatures of around negative 35 degrees Fahrenheit for several days in a row during February. Although it was difficult to hold a camera and perform the heater core testing, the video you are seeing is taken in extreme cold temperatures. The video on the left shows the heater core melting a hole in the ice, producing significant amounts of water. The video on the right tries to show the size of the hole by sticking the metal poker down the hole after pumping out the water. This video was taken after 45 minutes of heating 1000 watts at an outside temperature of approximately negative 25 degrees Fahrenheit. Water is pumped via a 100 psi 3 liter per minute diaphragm pump which recirculates water until the time comes to remove the water from the hole and send it to our water filtration system. The pre-filter system consists of 5 mesh filters housed in a multi-layer 3D printed structure designed to disperse and gradually filter the water. The mesh filters shown on the back right-hand side of the static picture range from fine to ultra-fine. The pre-filtered water is then passed through our final filter, the soil filter, which should reduce the particle size to 0.1 microns or less. All of these subsystems are currently functioning and controlled via 4 separate Arduino microcontrollers, which will all be integrated and fed back to a computer system for remote monitoring. All of these components eventually will be condensed and mounted in the waterproof electronics box on the system. Over the next 2 weeks, the electronics and control systems for each subsystem will be migrated to the full-size machine where the wires will be lengthened, circuitry will be finalized on perforated circuit boards, and the entire system will be retested to ensure proper function. That is the current status of the South Dakota State University JAMMER system. We look forward to meeting everyone at the Moon to Mars Ice and Prospecting Challenge in the fall.